So friends, the next algorithm that we are going to learn today is the K nearest neighbor algorithm. Obviously, it is a part of the supervised learning system only, and it can be used both for regression and for classification. So today we will do a coding based on K nearest neighbor classification, and we will understand the basic concept behind how a K nearest neighbor algorithm works. So for that, let us first draw a database. So friends, let's say this is our database. We have one category of data, which is this one, and we have another category of data which is represented by the green one. Now we have a new point that we want to classify or we want to categorize, and that point is located somewhere here. So visually friends, if I ask you a question, which category does this point belong to, the green one or the pink one? Obviously, visually you can clearly see it belongs more to the green one, right? Now, how do we create an algorithm that can simulate this kind of spatial understanding? So for that, the algorithm that we used is called the K nearest neighbor. So through K nearest neighbor, what we do is we assign the number of nearest neighbors that this point will count on. What do I mean by that? Let's say I say K is equal to 3. That is, which means the categorization will depend on the 3 nearest neighbors. Now here visually, let us say that the 3 nearest neighbors are this one, and let's say this one. So we have one pink neighbor which is very close to it and 2 green neighbors which are very close to this new red point. So based on the majority, what we'll do is we'll decide that this point is actually a green point. This point is actually a green point. So this is our conclusion based on the 3 nearest neighbors. We can also change this number from 3 to let's say 5, 7, 9, 11, like that. Now there is a reason behind choosing odd numbers, friends. We are choosing odd numbers because we want to choose the categories based on neighborhood. So let's say if we had chosen K is equal to 4 and the 4 nearest neighbors, 2 of them were green and 2 of them were pink. In that case, we will be in a fix, right? We will not be in a position to take a decision on the category of the point. But if we take K is equal to 5, then there is no such possibility, friends. Either there will be 3 greens and 2 pink, or there will be 2 pink, there will be 2 green and 3 pinks, or 1 green, 4 pinks, 4 greens, 1 pink, or there will be 5 greens, 0 pinks, or 0 greens, 5 pinks. These are the only possibilities. Now in none of these possibilities, there is an ambiguity. Obviously the uncertainty increases, but the division is clear. Either it belongs to the green or to the pink. There is no such thing that there is equal number of greens and pinks closest to a point. So that's why we choose odd number of neighbors to do the classification, friends. So this is the basic premise of doing a K nearest neighbor. So friends, the theory is not fully complete here, but we will straight away get into the coding part, and as we get into the different steps of our coding, we will learn the theories parallelly. So let's start with the coding first. So friends, the data that we are going to use is the wine quality data. Now here you can see we have certain chemical parameters here: fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, etc. And based on these features, we are trying to identify the quality. The quality has been categorized. So quality can be category 5, category 6, category 7, it can be category 4, or it can be category 8 also, as you can see in the data. So these are the categories that the wines have been divided based on the quality, and the quality is being defined by these different features. So how many features are there, friends? The feature count is 11. You can see it from here. This is the feature count, okay? And the data count, let's see the data count. The count of the data is 1599. Here the count is 1600, and this includes the labels also. So we'll do -1, and the data count is 1599. So fine friends, we are going to use this data and we are going to try and do some prediction of classifications. So let's start with it. So friends, to handle the database, we will use pandas. Import pandas as PD. Then to handle the numbers, we'll do a numpy. We'll import the numpy. Import numpy as np. For doing the plots, we'll import matplotlib. Import matplotlib.pyplot as plt. So these are the basic imports that we have to do. Now we have to take the database also. The database is winequality-red.csv. This is the database that we are going to use. The link to the database will be providing in the description below, so please check that out and you can use the same database and code alongside me. So df is equal to pd.readcsv. Because we are trying to read a CSV file, we are using the command read CSV here. Now let's see how the database looks like. You can see, friends, the same data that we used in Excel is being displayed here. Fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide density, pH, sulfates, alcohol, and ultimately the label, which is the quality. And the quality is of different types like 5, 6, 4, 7, 8, etc. etc. Now what we can do is we can divide the data into two parts. One is the output part, which is the quality part, and the other is the feature part, which is from fixed acidity to alcohol part. So let's do that. Now the feature part, we'll call it x. X is equal to df.ilog. We are separating it and we want all the rows. So we mention a colon. And we want all the columns except the last one. So we write colon -1 and we have our x. You can see here, friends, we have used all the data, all the features, and the quality column has been removed, right? Now we'll create a database Y which will have the quality. So df.ilog all the rows for which we only use a colon, and only the last column -1, only -1 we use here. Now see, if you press Y, shift enter, you will see name of the column is quality, length is 1599, and these are the categories. Now what we do is, friends, we will divide the data into training set and a test set. So for that we import train test split from sklearn.model selection, import train test split, and we split x and y. The splitting will be 20%, 80%, let's say. So x train, x test, y train, y test equal to train test split. We take the data from x and y, we keep the test size as 20%, that is 0.2, and we fix the random state. Random state, let's say, is equal to 42. So by fixing the test size and the random state, what we have ensured is no matter how many times we do the splitting, the data will be split in identical ways. So the first time if you split it, the split will be identical even for the 100th time if you just keep the random state and the test size same. So identical means never it will happen that some data was in X train and it in the next iteration or in the 10th iteration or 20th iteration of splitting it went into the X test. Never it will happen. So now we are ready with the splits, friends. Just for a sample, let us check Y test. Y test, you can see here the length of the data is 320, name of the column is quality. So if you want to ensure that the splitting has been done in 20/80 ratio only, let us do this 1599. It is approximately 20%, friends, 0.2001, right? So we have done the splitting properly. Now friends, we will do the k nearest neighbor algorithm setup. So how do we do that? From sklearn.neighbors import k neighbors classifier. Now we create the model KNN is equal to k neighbors classifier KNN.fit. We are going to fit the training data here. So we are going to train the model with the training data. So for that we use KNN.fit xtrain, ytrain. So we have trained our model, friends. Now we are going to do the predictions. So knn.predict. We are going to predict y values based on the x test values. So x test is the data we are going to use to do predictions. So here are the predictions, friends. Let us store it in something called ypred. So now we want to do a scoring of how the prediction has been. So for that, what we do is we type knn.score x test, y test. So our score is 0.45, friends. So this is like a percentage, and 45% is our score. So this is a very average score. We want to do some improvements on it. How we can do it? What we can do, friends, is we can do some tweaking of the parameters that we are using. What are the parameters, friends? So here you can see KNN is equal to k neighbors classifier. Here there is an empty bracket. Now let's enter our cursor here and press Shift Tab. Now you can see here, friends, n neighbors, that is the number of k, default k, here is 5. Okay. So we have used the number 5 to get the score. Weights is uniform by default. What is it? I'll get into details. Algorithm is auto. Leaf size is 30. We'll get in the details of this. P is equal to 2. Again, all these parameters we can do certain tweaks and find out which are the best parameters for our classification. So let's try to understand what each of these parameters mean, friend. So first, let us understand k is equal to 5. What do we mean by that? In neighbors. So the first parameter that we have is the number of k, the value of k. Here we have given only one value, 5. Now we do not know if we change the value, whether it will improve or not, right? We do not know if by changing the value we can improve it or not, but we want to give it a try. So giving a try means we give it a range of values. So 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25. So this is the range of values we are going to give it. Now the syntax, how we are going to use the syntax, we'll see it later, but this is the range that we want to use for it. Weights is we have used in default as uniform. Now are there any other options? Let's see. Weights. There are two ways to represent the weights. One is uniform, one is the distance. So in case of distance, what happens is, if the distance is more, the weightage of that neighbor decreases. So let me take you to the board here. Here, this was our point of contention, right? What should be the category of this point? This is close to this also, and this is close to this also, let's say, because k is equal to 5 we have taken, right? We will take the 5 closest neighbors. Now in case of uniform weightage, all these points, let's say the 5 closest points are this one, this one, this one, this one and this one. These are the 5 closest points, let's say. In case of uniform weightages, all these distances will be weighed equally. But in case of distance weightage, the points which have higher distance will have lesser weightage. So we want to try it out. So let's see what happens. So here what we'll do is, we'll go down to our coding page and use weightage as distance also. Distance. Right? Algorithm. Algorithm is auto kept here. So what we want to do is, we want to check if other options are available. We want to check a range of options. And how do we do that? So friends, we are trying out the range of options to find out the best combination of parameters, right? And to find out the best combination of parameters, we'll use something called the Grid Search CV, where we will put in all these ranges and Grid Search CV will give us the output with the best parameter combination that is possible. Okay. So the third parameter that we are going to use the range of is the algorithm. Let's see what are the options available in the algorithm. Here by default we have used auto, but I want to see whether other options are available. Okay. So let's see. Shift tab. Here in algorithm there is something called ball tree, there is something called KD tree and something called brute. So I'll be wishing to use all these options, friends. So let me copy these. And put it here. Now, if you are wondering what is a ball tree and a KD tree, for example, these are ways of arranging the database. So if we bifurcate the data into tree formats, it becomes much more efficient and much more time efficient in terms of doing the calculations of algorithms, right? So let's say let's go to our blackboard, friends. Let's say we have 7 pieces of training data. Training data. First is 1, 2. Then there is 3, 4. Then there is 5, 7. Then there is 2, 4. Then there is 2, 7. 6, 8, and the last one is 9, 11. Okay. Now, these first points are the X features and the second points are the Y outputs. So the X features, if I want to separate them out and arrange them in a sequence, they become 1, this one, then 2, 2, 2, 2, then 3, then 5, 6 and 9. 5, 6 and 9. Now I want to arrange the data in the form of a tree. Okay. So to start with the tree, let's say we are starting with the midpoint. Midpoint means where X is 3. So the midpoint is 3, 4. And the greater ones will go to the right, this direction, and the lesser ones will go here. For each of the nodes, this is the case. Now on this side, that is the lesser side, the midpoint is this one. So this is going to be 2, 4. And here on this side, the 6 is the midpoint. So it will be 6, 8. So these two are done. And if we further bifurcate it, on the right hand side of 6, 8 will come 9, 11 because here the greater numbers will be placed. 9, 11 will come here and 5, 7 will come here. On this side, 2, 7 will come. Because 7 is greater than 4, we are putting it here. And on this side, on the lesser side, 1, 2 will come. So the entire data has been arranged in a tree format. So this KD tree, ball tree, These are all formats of arranging the data, and this makes it easier for the algorithm to reach to the answer at a faster time. Okay, the time complexity reduces with the arrangement. So we are going to choose all the algorithms and find out which one is doing the best in terms of performance. So here we have chosen auto, ball tree, KD tree, brute, all of them, right? Again, I'll repeat, we are including the ranges, but we are going to change the syntax here and use it in the grid search CV. How? Let us wait a little while, we will understand. Leaf size is 30 given here. So what I can do is, I can put a range from 5 to 50, let's say. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. This is the range I am going to use. P. So let's understand what is, okay. So leaf size, I have given the range here, but let's say we do not know what is the meaning of leaf size, right? Now friends, what is a leaf size? So first, before we understand what is a leaf size, we have to understand what is a leaf, right? So you can see this decision tree here, right? This one. Now, these points or junctions, these are called nodes technically, right? And those nodes through which the decision tree ends or culminates are called the leaf nodes. So here, this node, this node, this node and this node, these are the leaf nodes. And therefore, leaf size here means the minimum number of data points or the minimum number of values the leaf nodes can hold. Leaf size in this example is 1, right? In our coding page, we have given a range of the leaf size that is required. And we want to understand which leaf size gives us the best performance. The score for us is 45% approximately, which is not that satisfactory for me. So I'm going to try out different options and find out which one works the best. The next parameter is P is equal to 2. Let's understand what is P. So P is basically the distance parameter. When P is equal to 1, it represents the Manhattan distance. When it is 2, it represents Euclidean distance. So what is Manhattan distance and what is Euclidean distance? Let us understand that. So friends, we had a database here, 1, 2, 3, 1, 2, 3, 4. Let us plot these 2 points to understand this. So this is our axis, friends. X-axis 1, 2, 3, 4. Y-axis 1, 2, 3, 4. And the first point that we have is 1, 2. That is X is 1 and Y is 2. So this is the point. And the second point is 3, 4, right? 3, 4. So the next point is X is 3, Y is 4. So this is the point, let's say, approximately. Now what is the Euclidean distance between these 2 points and what is the Manhattan distance? So friends, the Euclidean distance is the straight line joining the 2. So this is the Euclidean distance. Now how do we measure this distance, friends? This is simple, friends. The points are 1, 2 and 3, 4, right? So the Euclidean distance will be calculated as ED is equal to root over of sum of 1 minus 3 square plus 2 minus 4 square. The Euclidean distance will be calculated as ED is equal to root over of 1 minus 3 square, that is the x coordinates, plus 2 minus 4 square. This is the Euclidean distance. You can calculate this. This comes to be root over of 4 plus 4. This is 2 root 2. You can convert it into decimals also. 2.828. Right, friends, this is the Euclidean distance. Now what is the Manhattan distance? The Manhattan distance is this one. The Manhattan distance is this straight line plus this straight line. So why the name Manhattan distance? It's pretty simple, friends. let's say in Manhattan you want to go from here to a point which is here. Now you cannot go straight because there are buildings. There are buildings like this. So what you have to do, you have to bypass these buildings and go here and then go here. So that's why the Manhattan distance. So the Manhattan distance is calculated as MD is equal to 3 minus 1 plus 4 minus 2. This is equal to 4. So we do not know whether Euclidean distance is going to work better or Manhattan distance. So we are going to use both the parameters and try them out and understand which one works better. So here P is equal to 2 means Euclidean distance. P is equal to 2 means Euclidean distance, right? And P is equal to 1 means Manhattan distance. So we'll try out both the parameters or both the parameter values. So here P is equal to 1, 2. Metric we will ignore for now. So we have our parameters here, but friends, this kind of format will not work. We'll have to make a dictionary out of it. So how do we create a dictionary? First we replace the equal to's with colons, and then we have this range of values which we turn into arrays. So this becomes an array, colon, array, again colon, array, colon, array. Same for the last one, colon, array. And for dictionary, let us call it the parameters. So for dictionary, it will be within second brackets, right? And each of these elements are separated by commas. So we are done with our parameter creation, right? So these have to be within quotes. Now we have to import what we used to call grid search CV. So from sklearn dot model selection import grid search CV. So CV is equal to grid search CV, shift tab, estimator is KNN, then parameter grid, which is parameters, then scoring, njobs, repeat, refit. Let us give it CV is equal to 5 and keep the rest as it is. Now we want to find out the best parameters, right? So for that, first what we have to do is we have to fit the data once again to this CV. CV.fit xtrain, ytrain. So friends, the model has been fitted. We want to find out the best parameters, right? So CV dot best parameters. See, algorithm auto, leaf size 5, neighbors 23, P1, so 1 means Manhattan distance, weights distance. So there has been some changes from our previous performance or from our previous parameters. So now with these new parameters, let us again find out the prediction and the scores. So KNN is equal to K neighbors classifier, and we are going to use these parameters. N neighbors is equal to 23. Then weights is equal to distance. Weights is equal to distance. algorithm auto, so we'll not change it. Leaf size 5, so we'll change it. Leaf size 5. P is 1. P is equal to 1, which means Manhattan distance. Now we have created our new model. We'll be fitting the data with this new model. X-train, Y-train. Now the training has been done. So let us find out the score of this new model. KNN dot score X test Y test. See friends, the initial score was 45.6%. Now the score is 62.18%. That's a drastic change in the performance, friends. That's a drastic change. So friends, we can conclude here that the K neighbors has performed much better when we have done the best parameter selection. So friends, the score is obviously better. Now we want to measure the performance of it through the confusion matrix. So let's do one thing. Let's first find out the predicted values of Y. Ypred is equal to KNN dot predict. The KNN model has been fitted already, so we can use it for predictions. And the test data will be used for predictions. X test data will be used. So this is done. Now what we'll do is from sklearn import matrix. So we'll be use matplotlib to create the confusion matrix, and we'll explain what that is, and we'll do it in a heat map form. So all this we'll explain. Don't worry. Just in a while you'll get the understanding of it. So from sklearn import matrix. Now the confusion matrix CM, or the confusion matrix, is equal to, in the description the logistic regression chapter has been, the link has been provided. If you have not understood what confusion matrix is yet, please find the link to logistic regression that I have provided in the description below. There the entire confusion matrix and how the performance is measured through a confusion matrix has been explained in every detail possible. So you can just go to the link and find out. You will learn about logistic regression also, and you will learn about confusion matrix in the process. So it will be best if you do that. So here we will come back to the creation. So here we'll come back to the creation of confusion matrix. Confusion matrix is equal to matrix dot confusion matrix. Confusion matrix will be using the true data and the predicted data for this. So Y test is the true data and Ypred is the predicted data. So we have used it to create the confusion matrix. Now we want to plot it. So confusion matrix plot is equal to matrix dot confusion matrix display confusion matrix. We are using the previous confusion matrix only, and if you go to the data, we want to figure out what are the labels that are going to be used. So here if you come to the data, you can see in the quality section the labels are given. So our classification will be 5, 6, 7, 8, etc, etc. So what is the range of these labels? Let us understand that. So for that we just sort the data. Smallest to largest, sort. So we are starting from the value of 3, category 3, and ending at category 8. So 3 to 8 will be our category labels. So here we will write display labels is equal to array from 3, 4, 5, 6, 7, 8. That's our display labels. Okay. There was a mistake in the bracket selection, so we have corrected that. Now we are ready with our confusion matrix plot. Now we just need to show it. Confusion matrix plot dot plot. and plt.show. Now we have come with our categories and the numbers. So what do these numbers mean, friends? Let us take the middle number, number 96 here. So this 96, this one. So below 96, if you go vertically downwards, if you check the label here, the predicted level is 5 and the true level is also 5. This means that in 96 cases, we predicted category 5 correctly. And if you check out the diagonal numbers, all these diagonal numbers 0, 0, 96, 88, 15 and the last one 0. So you will see these are the true predictions and rest all others are false predictions. For example, 32. If you take this number 32, this basically means if you go vertically downwards, you will see predicted level is 6. And if you go horizontally leftwards, you will see true level is 5. So in 32 cases, true level was 5 and the prediction was made that it was 6. So it was a false prediction. While in 96 cases, the true level was 5 and it was predicted correctly also. The second, let us take this number 88. This basically means that in 88 cases, the true level was 6 and it was predicted correctly also. In 40 cases, the true level was 6 but our prediction model said it was 5. So it was a false prediction. Like this, every box you can define in this way, right? So that's about it, friends, for our k nearest neighbor calculations. In the next class, we will talk about support vector machines. This is also a supervised learning algorithm. We will understand what is the use of it and we will do coding to understand the exact applications of it. If you found this video helpful, friends, do like, share and comment on these videos. Do subscribe to this channel. This course is going to be a complete course which will cover a plethora of algorithms from supervised learning, unsupervised learning and reinforced learning. All the algorithms you will be able to access here. And in the GitHub links, you will find the practical codes that have been done in these videos. So do subscribe to the channel and this is going to be very useful for you for your knowledge gathering and also for job interviews that you are planning to give. So stay tuned. Thank you for being with me in this video. See you in the next one.